you have like selected your materials, could it also build in how that works structurally? Like if it's actual the proper load bearing?
Yeah. You can start our recording. I have the answer for it. Yeah.
Wait, stop or it's recorded
You can
now.
start. It's already recording. Yeah. Okay.
Yeah. Did you notice that at the beginning you said Virak? You will notice that there is a gap between this and this.
Okay. Yeah.
I know the answer. You can start recording.
I know the answer. You can start recording. I can't double record. Okay, I'm gonna start just recording it on my phone. Okay, how about that? We're just gonna double record this.
My bad, G. Sorry.
Thank you everybody for joining us for another episode of Unfuck the Internet. We're here joined today with, of course, the lovely Amanda Rosita out in Rome, Italy, and of course, our good friend from school, Mr. Reddy. Yes. You can say hi now.
Namaste.
No.
Namaste,
Reddy. That works as well. Yeah. So Reddy is a asset management consultant living out in Stockholm, Sweden. We asked him here to join us today so we can talk a little bit about sustainable architecture. Reddy, do you want to just touch a little bit about what it means to have sustainable architecture?
Yeah, sure. I mean, everybody's aware with what is happening with the climate and what kind of stress the government is putting on everybody in general, and what kind of progress we're doing with, for example, the COP summit that happened quite recently and so on. So it is very important for all of us, and especially the engineers who are going out and engineers and architects who are going out and designing buildings, to be able to have all of that in the back of their head and simultaneously create value for the client, for the environment, and for ourselves in doing generative and sustainable beautiful designs and architecture. That's the thesis of what we're going to be trying to discuss today, and what in general technology or the internet in general has let us achieve so far, and there's a lot of exciting things that are going to come up in the future that we can keep talking about.
Excellent. Yeah, that sounds good. And that was a little bit of an awkward pause, but we're just going to roll with it. So could you just talk a little bit about how, like, I remember from just some of the architectural programs that I remember talking to, or friends who I have in architectural programs, just some of the small steps that they have told me about how to make sustainable practices. So one thing I remember learning about is what is that called again when you put grass over a roof and you kind of like bury it into a ground? I think it's like a specific name to it. It's like a Nordic garden. I don't know if it's called like a garden roof. No, but it's like specific. It's kind of like, where you literally put like the building into like a hill and then you cover it with like the soil, the sod, the grass that goes on top of it.
So this sounds to me awfully like Bag End. Do you know Lord of the Rings?
Again, yes, that's exactly actually what I had in mind when I thought about that, because I heard that well, correct me if I'm wrong, doesn't that help insulate the building more so that way there's less heat escape?
Yeah, it does, and it's called green facades, building green facades.
Facades. Okay.
Green facades, and so it does actually help quite a lot with insulation, but again, that is to its sword, because soil actually absorbs a lot of water, and so you can have damage to the roof and so on if the insulation is not proper, and over time there may be some issues and so on. So always nobody's going to accept any form of sustainable practice if it is going to disrupt their common or the general way of living. So that's a general mindset of people. I mean, for example, take your own place. Imagine if you have a green facade up there on the roof, it all looks cool and everything, but then imagine if the paint started falling off. Would you rather have that, or would you rather be like, okay, I'm just gonna have a lawn outside and just offset my carbon somehow and do something else, rather than having to deal with repairs, which again costs, which again would cost to more if someone comes and has to repaint and rework. So it's you're putting off more CO2. You're increasing your footprint rather than saving. So,
Right. Okay. So it's all kind of about like offsetting the cost
yeah,
of
exactly.
living in the house or going into it.
Ex-
So what kind of tools go into helping, say, architects or planners design a more sustainable building or a more sustainable project?
Using
Okay.
softwares for that?
Yes.
Yeah,
Yes. Specifically using softwares.
there are quite a lot of tools out there, but from the beginning itself, instead of just building standard buildings like with what we already know, which is build standard buildings, all the buildings looking the same, it's much easier for the architect. It's much easier for the architect and much easier for the construction guys also, because they've done it time and again. But the new concepts that are coming now into the market, they're like generative designs. So design
Okay.
that are specifically suited to work around what are the client's needs, while simultaneously reaching reaching their sustainability targets. A simple example could be, uh, again, the house that I'm living in for now. For example, let's say it was an empty plot, and we start designing. Yeah, so there are three main components with which we calculate the CO2 footprint for any given building. Yeah,
Ooh.
so
Okay.
so that's A1 to A3, A4, and A5. So A1 to A3 is the base is the base CO2 cost for producing the material used in the construction. For
Okay.
example, if it is concrete, or if we used steel beam, for example. So we know that for manufacturing 1 kilogram of steel, that much how much CO2 is being put into the atmosphere, because it needs to be removed from iron ore, it needs to be melted, and
Okay.
so on. Yeah. So the second thing is A4. So it's called the transport aspect of it. So from the place where it was manufactured, let's say steel, Sweden has a lot of iron ore reserves, but they're all up in the north. So for somebody to transport all of that here, so for transportation, you have to offset that. You have to calculate that. Okay, to bring that
Okay.
material from source to the destination, there is still CO2 involved. The third thing is third thing is installation and actual working, and also waste. So let's say you bring in 1 kilogram of steel, but then you don't end up using all of it. You machine it off, or
Oh, okay.
you bring wood, you chop it into pieces, the sawdust goes to waste, and this and that, everything goes, a lot of it goes to waste. Can be concrete. So now I'm just strictly talking about building materials. I've not
Okay.
gotten to the interiors yet.
Right. Okay. We're not like
Yeah.
iterating out to like calculate
No.
the personal CO2 footprint that each worker
Uh,
involved in each one of the steps
yeah.
goes.
So this is layered. So this is the top layer, and then you break it down further and
Okay.
further and further as you go down. And so these are three main factors, yeah, that contribute to the building CO2 footprint, just from the materials perspective.
How do you
Uh,
how do you measure that in manufacturing?
oh, this has been measured for a lot of time, actually, ever since 2000, 2006,
Oh, wow.
2005. We've already known figures for, even earlier, I think we've already known figures for how much CO2 is being put out into the atmosphere for producing a unit mass of a material. That goes, basically called life cycle analysis.
Okay.
Yeah, so
Wow.
in as part of this life cycle analysis, the we know the original manufacturing, the transport and the waste thing, they're relatively new, but the original, the main contributor of main contributor to the pollution in general, that we already knew. It's been a while since we knew, and it's kind of sad that it's only now that we're kind of acting on it. um yeah, as I was saying, generative design, a simple alternative could be, instead of bringing steel from far away, can we look for steel close by?
So
Or
reuse
is
Ooh.
the steel that has been like wasted somewhere
Yeah,
close.
exactly. Wasted, and it is also close by. So the CO the the carbon has already been offset for that material, and then we're just going to reuse it. That's all. And so that way you're not going to have the A1 to A3 component of the carbon footprint anyway. The second option is just, do we have to use steel? We can use, I don't know, reinforced other reinforced plastics, concretes, or this, or wood.
Ooh.
Timber, for example.
Mhm.
Timber is a very good alternative for buildings, especially. Historically, we've done that. We've used timber in a lot of construction, but they stopped because there's a lot of fear with fire. But I mean, the recent advents we've made with fire suppression, fire retardant technology, and the in general response time of the fire brigade is crazy. So you don't, so that's no longer a problem, a serious problem anymore. It is in some cases, but it's no longer a serious problem anymore. And also from an insulation perspective, wood is amazing. You know, it keeps heat outside, it keeps the cold outside. Yeah, so wood in general is
Especially
plywood
for
also.
Sweden, you can find it
Yeah,
everywhere in Sweden. So it's just like
yeah,
all the
yeah.
way around.
Exactly. In Sweden, especially because we have temperature extremes,
Yeah.
and
Right. Yes.
I mean,
yeah,
not really
and
extreme in summer, but yeah, in the winter it's pretty extreme. Yeah.
hey, the last summer was 28 to 30 degrees, the hottest day, and the coldest
Okay.
day I think, yeah, and the coldest day I think
Yeah,
was, I don't know, plus
notice how I'm in agreement with you, but Amand is just like whatever. It's 28, 30
yeah,
I mean,
degrees.
yeah, I'm from Italy, and for me, it's just
yeah,
28 normal temperature. But for
yeah,
Sweden, I mean, I've been living there. That's pretty hot.
yeah,
Yeah.
yeah,
Yeah.
yeah.
And
So
isn't there a
it's
development
not
in
just,
Helsinki that has like its entire, like they're building like an entire development made out of wood somewhere in, it's
yeah,
either Helsinki or in Finland.
uh, uh, Helsinki, I'm not sure, but I know that there are buildings like that in Oslo. Oslo is amazing.
Awesome.
They've
Okay.
done
Amazing. Yeah.
Oslo,
I agree.
yeah, and to add to what Amanda was saying, it's not just what is the highest and what is the lowest temperature. It's the difference between the highest and lowest temperature
The
that
gap.
engineers,
Right.
this the delta T. That's what engineers are
It's
always thinking.
called Delta T.
Yeah, delta
Yeah,
T.
because I can
And
totally understand that, especially in places up north, like here for instance in Southern Ontario, we get what is our temperature extremes? Our delta T will be positive 30 in the summer to negative 22 in the winter.
yeah,
So
so
50, 50
Yeah,
yeah,
of
it's a 50-degree kind of change for there. So do you know of any techniques or any developments going towards like extreme temperature divides?
yeah.
except the
So
wooden.
Yeah.
there are, especially in Sweden, there are, and if you the more north you move, you will notice that in actually quite a lot of constructions. So what they do is they're building houses in layers, and they have air gaps in between them.
Oh.
Air is one of the best insulators there is. I mean, like there can be literally like a 4,000 degree, like somebody can be literally welding at 4,000 degrees Celsius,
Mhm.
but you can put your hand right there, and it's it's bearable. You know, so that layer, that thick layer of air can reduce 4,000 degrees on one end to 38 degrees. And so, and imagine if we did that for a house, and the air was in a controlled environment.
Okay.
So that's something that they're trying to that they've done and now what they're trying to do is trying to insert air within the wood itself. So they're kind of have planning to have porous wood like plywood, for example.
Okay.
And so that would basically reduce the structural integrity of the wood itself,
Mhm.
but then it would increase its insulating properties.
Mhm.
Yeah, and then what they do is around the wood just add rebar or just a couple of
Okay, to make
steel
it like
beams, and then
stronger, kind of.
yeah, exactly. So you basically having the best of both worlds. So you
Mhm.
have the structural integrity along with insulation. So that's yeah, off the top of my head, that's just one example. There's so many other things that uh, we can do to make more sustainable choices. Oh yeah, one other thing, how how data and specifically internet is
Yes.
helping us. How data and specifically internet is helping us in making these sustainable choices. Yeah. So on average, for a building, there are roughly, I don't know, 15 to 20,000 different materials used.
Okay.
Okay.
Now, yeah, it
Sounds
can
like
be, yeah,
It's a lot. Yeah.
metal, yeah, uh, uh, alloys, wood, plastics, cables, trays, heating, cooling elements, floorboards, yeah, you name it. There's a lot of different materials that are used with a lot of different uh, properties, consistencies, and key important factor is a lot of them have a lot of different CO2 footprints. Some materials are amazing; they have no CO2 footprint whatsoever. But some materials are you're like, what the hell, man? Seriously, stop using. Yeah,
You're literally just
really.
filling the apartment full of coal, and it's
yeah, yeah. That would be better in some cases. You know, these some of these materials, it's crazy. No, just to make like a kilo of metal, let's say, do you know how
okay.
much water goes in? A lot of water is
Oh.
wasted, a lot of
Oh.
and a lot of energy is taken. So to
Mm-mm.
produce that energy, you have CO2, and then to purify and to heat it up or to shape it, you have CO2.
Yeah.
To machine it, you have CO2 going out to the atmosphere. So
I
it's
mean,
crazy.
it's even
That's a
worse
lot.
that they fly it into sight on a helicopter. That would be
Exactly.
Mhm.
And so this is this is something, and so there's so many materials, it's so much data, right?
yes.
Yeah,
So
a lot
now,
to control.
yeah, so right now there are, I mean, at least at my company, and I know for sure there are some companies out there, some other companies out there that are also developing tools like this. But the general gist is this: you have for the same building, the same exact layout, yeah, the same exact layout. For the same building, there are different scenarios that are generated. So let's say you use material A, material B, material C. So
Okay.
there are algorithms out there that test different materials in different places of the house, and then they give you the output of the program is basically what is the cost going to be for the project, and what will be the overall CO2 footprint, and what will be the running CO2. So once you actually start
Oh.
living in that place,
Until the house,
what will
kind
be?
of.
Yeah, exactly. So you have these three outputs, that three main outputs. You have many others, and so usually for myself, if I'm sitting in front of a computer and then trying to pick what kind of material I want to make the building out of, it would be impossible because there's so many materials that I could use, and every material has different properties and so on. But the
Okay.
algorithm, it would just do all of the calculations basically simultaneously, and you would have you and then the clients also have they play a role. some
True.
clients they're some clients they're evangelical, so they're like, oh, we need to have the most pristine, the most lowest CO2 footprint building ever.
Okay.
Some people could not give a shit, really. Yeah,
I
so
want
They
you to
want to
build this floor out of gold. That's it. Just
yeah.
straight up.
Yeah, so there can be some clients like that, but more often than not, they're, at least in the Nordics, they're a little bit more conscious, I would say.
Mm-mm.
Gotcha.
And yeah, so those, based on those three outputs, your decision making is fastened, you're making smarter decisions, and also you're basically contributing to um yeah, reducing the footprint of the building. And also that comes with a lot of significant tax breaks as well.
Mhm.
So
Of
yeah,
course.
Like,
so that's really interesting for a lot of companies. So
like, for example, if I'm a customer, I can decide,
yeah,
I just come to you and I can
yeah,
basically like see the different scenarios, like with different materials and prices along with that and stuff like that. But can I also see like the
exactly.
design of it? Like, do I have a visual connection with that? Like, can I see the output visually on the
Yes,
software?
yes. Yeah, yeah.
Yeah.
The software, what it actually will do is it will render out a 3D model of the
Oh
building.
wow, already.
Yeah, yeah.
Ooh.
Oh.
And so it would render out a 3D model of a building. And have you guys seen these heat maps? Like, if you
Yes.
see,
Yeah, of
and
course.
IR lens. Yeah, so some places really hot, some places cold. Yeah,
Mhm.
you must have seen heat maps, right?
Mhm.
Same principle applied to the building, but then instead of heat, you're trying to measure CO2.
Oh, wow.
So you will so
Oh,
over the building,
Wow.
you will kind of get like a heat map and the areas where you would need to focus. So let's say the front of the building is fully red and the rest of the building is white. So then you know that most of your CO2 footprint is coming from, the material you choose to make the facade,
That's super
okay.
and yeah, and you can just simply just, hey, you know what, change it, or just delete it, and or you can so this basically enables dialogue with the client.
Okay.
So then, uh, as responsible engineers, we need to try and tell them, hey, so it's not so good. Try and take it off. But sometimes the clients are like, hey, we're still falling within the benchmarks, yes. But then, I mean, come on, look at it. Just one small thing, if you would change it, then
Okay.
you would have a future-proof building. Like 25 years into the future, you would still be carbon negative. Like, there's a lot of
wow.
there's a lot of discussions like this, and um, yeah, that and cost. Yeah, the cost
Yes.
is that's what drives 99% of the decisions. Yeah,
Yes.
yeah,
Keep
yeah.
everything
Think
as
so.
cheap as
Yeah,
possible, please.
yeah, exactly.
Yeah,
So
I
as
agree.
cheap as possible, but it again, as responsible engineers, it is our duty to tell the client that, okay, let's say you spent $1,000 on something that looks good but it has a horrible carbon footprint, but uh, you can just spend, I don't know, maybe $4,000, $5,000, but over time it would pay for itself. A very good example for it
Ooh,
is
okay.
just just the insulating just the insulating material for the wall, or uh, um, the lining for a window. It's something completely small. Yeah,
Okay.
it's really small. Now we're not talking about CO2. Now we're talking about running CO2 when people are living in the house.
Oh,
So,
okay.
so let's say there is a lining for the window that is okay at trapping heat, but it's super cheap and it's very easy to install. So people are gonna
Okay.
buy it. And but what they don't realize is, like, I mean, they're using a lot of heat inside, and that seal is letting the heat escape out.
Mm.
Right. Okay.
Yeah. So they're every month they're paying a lot more in electricity bills. So instead of paying $1,000 at once, if they paid $4,000 in the beginning, in the lifespan of the product, which is usually 20-25 years, within the
Okay.
first 5 years, the product would have paid for itself, and the next 15 years,
Oh.
technically, you're making unrealized profits.
Yes.
Based
And
off
Long
of
term,
like,
you take advantage of
this,
it.
yeah. So this is just one
wow.
window lining I'm talking about.
Mhm.
So there are there's so many examples in my head. Sorry, like
Reddy is
uh,
just ready to explode with enthusiasm here.
yeah. So
Um,
so that's the thesis basically. So you as responsible
okay.
engineers, you need to try to have a dialogue with the client, try and explain to them what kind of benefits there are, and not just thinking straightforward about costs.
So just to take it back to the whole heat math and the sustainable practices again, in how does that build into, say, the engineering side of designing, say, like a building? Say, for instance, if you have like selected your materials, could it also build in how that works structurally, like if it's
Oh,
actual the
I
proper load
yeah,
bearing?
yeah. You can start our recording. I have the answer for it. Yeah.
Wait, stop or I it's
You
recorded
can
now.
start. Oh, it's already recording. Yeah, okay.
Yeah. Did you notice that at the beginning it said Virak? You will notice that there is a gap between this
Ah,
and
shit.
this.
Okay. Yeah. Hmm.
You
So,
could, I know the answers. You can start
I know the
recording.
answer. You can start recording. I can't double record. Okay, I'm gonna start just recording it on my phone. Okay, how about that? We're just gonna double record this.
my my bad, G. Sorry. Yeah. Um. So the heat map that we were that the heat map that we were already talking about. So what the heat map basically does, as we were talking earlier, it says okay, which areas of the building or which areas of the property or the asset we need to be looking at to reduce our CO2 footprint, correct? Uh,
Yes.
but the flip side of that is, let's say you mentioned why can't wood beams be used. Again, wood beams would not be structurally sound enough to make, if they're key load bearing members,
Yeah.
wood wouldn't work that way. I mean, it does, but only to a certain extent. If you're talking about buildings like this house, for example, if it's 3 floors, then the wood is not going to do.
Okay.
So there needs to be rebar or some kind of additional structural elements that needs to be added. And this is where, again, if you work a lot with data, it can help you make intelligent, smart decisions.
Okay.
So you know what is the level of load that is falling on the ground floor, yeah, the
Okay.
foundations, let's say, and the mechanical properties of materials are already known. You know what is the ductile strength, what is the compression, how much load bearing, what kind of elements can capture how much load. We know
Okay.
all of this already, but different materials have or it's set of different properties. So if you set a baseline that says, okay, this is the maximum load that the material has to bear, so that significantly narrows down the number of materials available for you to choose.
Okay.
Yeah. So in that,
Oh.
then there is, we can talk about this in BI terms. So you put filter on filter. So you're
Oh.
drilling down.
So
You're
you're
drilling down.
literally, it's like a drill down, kind of like it's like a flow
Exactly.
in a way.
Exactly. So the
Interesting.
first level obviously always has to be safety. So that's what I was talking about. So that's the load bearing capability.
Okay.
So the next steps of how we drill down. So this is up to the client. So if the
Right.
client says cost is my number one priority, that's the first thing that we will drill down on. So we know we're
Gotcha. Okay.
narrowing down faster and faster and faster. But if the client says, hey, we need a little bit more sustainable, then we can say, hey, sustainable, and within sustainable materials, which is the least and which is
Gotcha.
the highest.
And
And
which is the
then
highest?
once you have it down to 2 or 3 or 4 materials, then you just take a yellow Lego pad, make pro con lists, discuss with your client, and then you're good to go.
Nice.
Nice.
So that's how you drill down from thousands of materials to making more sustainable and cost efficient choices.
Nice. Very
Yeah.
interesting. What if I'm a customer and I want to go on site? So I'm just gonna I have to build a building and it's gonna
Yeah.
be on a piece of land, and
Yeah.
you have provided just like a design of it, but I only can see that virtually. So I can see that just like on the computer. What if I want to go on site and I wanna visualize that just in front of me? Like, do you have like kind of like VR
Yes.
or stuff like
Yeah.
that?
No. That wouldn't be VR. VR would be completely, you'll be completely in a virtual environment. So
Right. Yes.
that's not anything different from looking at a model on a screen.
It'll be
Really.
AR then, right?
Yeah, exactly. That's what I was
Augmented
getting at.
reality. Okay.
Yeah, it'll be
Wow.
AR.
You also
So
have that?
yeah, we do. So you go. A lot of guys working in construction nowadays have that. So what they do is they basically go. I will explain the existing technology first and where the market
Okay.
is heading.
Yes,
So
please.
the
Thanks.
existing technology is, so let's say I'm an electrician, yeah, and I need to go and look into open the ceiling up a little bit, look at some of the cables, what's happening there, and I need to perform some repairs. Yeah, but
Mhm.
this is the first time I'm visiting that site, so I don't know what the hell is going on up there. What I can
Understandable.
do is, yeah, so they have these wireframes of where different plug boards are, where different wires are in augmented reality. So like they have an iPad. So basically they give 2 reference points. So this is the entrance of the house, and this is the first or second reference point, which the computer already knows. Then it knows the measurements of the house, and they already have they already know. So 10 meters away from the entrance and at 5 meters elevation, so there is this wire.
Mhm.
So
Okay.
this guy can basically just walk in, not looking outside, just looking at the iPad, walk in, and through the camera he just points it out.
Ah,
Oh.
I can see it. Okay.
Okay, so there is that wire I was looking for.
Oh,
Okay.
And
okay.
it goes and then
Right.
does the replay. Future
Interesting.
is the future is once we so we do use, a lot of guys use, uh, game development. So we do there's this Unreal Engine, you guys must have heard of
Right.
it.
Yes.
You use Unreal Engine, you render out something, and then you set base layer, and then you can pull the model into into real environment. That is so that's where it is headed right now. It is just that looking for individual components or individual systems or subsystems within an already mapped environment.
Okay.
The future is going to be like, okay, I have a building plan, but I have 7 or 8 different empty sites to choose from.
Okay.
So I can
Okay.
go, I can look at, or I can just go and turn the building like this, north south facing, so to maximize sunlight into the building and so on. So
Decide to place it on a hill or
yeah,
not. Yeah.
the client can do that in augmented, like as you were asking for, Amanda. You can do that in augmented reality, but then simulations are much faster, cost effective, and you basically end up arriving at the same result. So uh,
Okay.
a lot of people tend, so we exactly know where the sun is going to come up, where the sun is going to go down, and how long exposure we have to the sun, especially in the Nordic regions where it's super important. Yeah, it gets dark all of the time.
There's
So
no sun, basically, you know.
Yeah.
so we're trying to maximize how much sun we can possibly get. So so we already know all of that, and then on top of that, we also know what are the exact coordinates where the site is planning to be built, and we have ArcGIS, so which means we have a satellite imagery of the entire globe basically, and so
Wow.
we can just place our building wherever we want, and we can assess in my bedroom how much sunlight do I have between 10 to 12 in the afternoon or in the morning.
Wow.
Oh my
Yeah,
God.
you
That's a
can
lot of
already.
information to process.
Yeah,
That's really a lot. Sorry, I talked
yeah,
over you. Continue.
it's completely fine. And that is actually a genuine problem that is actually halting progress. So the
Oh.
so the laptops that we have now, where we're running all these tests, and
Oh.
so they hit enter, the fan
Oh yeah.
starts.
There's not enough
Yeah,
RAM to process
Yeah.
everything.
exactly. So now we're going to go more towards cloud computing. So
Uh-huh.
Oh.
our model, everything gonna live. So Autodesk is one biggest companies out there. So
Mhm.
Okay.
Autodesk and Rhino. So there are two. Rhino is for structural. Autodesk, or most AutoCAD products are for detailed installation related design.
Okay.
Mhm.
At least at my job, that's the way they are.
Okay.
So Rhino is actually developed by American and Canadian startup. It's a American and Robert McNeely Associates. They were architects to begin with, so they developed all these, and so now those original companies that came out with the software, now instead of selling licenses, they're selling cloud space.
Mhm.
Oh, that's a smart
Yeah,
practice, actually.
yeah. So they're like, hey, we're just gonna give you so much space. The computer here is gonna have, I don't know, 256 gigabytes of RAM. Yeah,
What?
crazy processing
Holy
power.
crap.
Yeah, you can do what the hell you want. You can basically build a small
A city.
Minecraft world in there. Yeah,
Yeah.
Terabyte, right?
yeah. So it's a lot of a lot of computing power that is necessary, and a lot of software developing companies, they're also offering. And I think it's going to be a bright future. A lot of people are really interested to try this out. A lot of companies have already started trying this out in pilot projects. And um, let's take, I don't know, a long bridge, the bridge between Copenhagen and Malmo. Do you remember?
Yes.
Oh yeah.
Yeah, the very long
Office
Yeah,
one.
was the
yeah.
office
So
was
the one that, yeah, exactly. So it was actually designed here at Rambo.
Oh
So
Oh, no
wow.
way.
yeah,
That was a big
yeah. So
project, right?
yeah, it was a very big project. So uh, uh, so there is over, and then it goes on down under, and then it's a
Yeah.
Yes.
seabed tunnel.
You got
This,
range down under,
yeah,
yeah.
this is crazy. Yeah, the construction itself is crazy. But imagine you try to calculate loads on the bridge when there is wind and there is sea
Or
influencing, as you see.
sustainability as well.
Yeah, also, and so that's historically was super hard, but now you just upload them all somewhere and you can basically do most of the calculations.
Okay.
And
Do you also
that's
have
where
a line under the bridge for the cars or just train?
you can drive.
Yeah, you can
also
drive it. Yeah, I took a
Yeah.
bus from Jönköping to Copenhagen, and we went on the bridge.
I also did. I completely forgot it. Yeah, I did it like many times actually, and I forgot it.
I think it's trains, buses, and trains, vehicles, and there's high tension power cables going along, and also I think natural gas. There's a pipe.
Right.
I
Now,
think so.
Reddy, when people talk about sustainability and buildings, I think like the most cliche thing, especially here in North America, that you hear all the time is we're going to put solar panels on the roof and some wind turbines nearby, and then we're good. Is is that like a feasible aspect, or what is your comment on say like the energy side to buildings?
Okay, my comment is the biggest problem with all this like solar or wind, what the biggest problem, there is abundance, it's not a problem. The problem is capture and storage.
Right.
So I think on one of your previous podcasts you talk a lot about hydrogen
storage
fuel.
problem.
Yeah, our last episode of Mattia.
So that kind of solves the storage problem, but it's not widely accepted by the masses. There are safety concerns with hydrogen fuel, this and that, and I mean, I'm pretty sure you guys must have discussed that at length. So it's just that you're not able to generate it constantly enough, and there's not enough storage. So I mean, there are some places here in there are some companies here that what they do is they generate electricity when they can, they sell it to the companies, and then when there is peak load, so when you're supposed to pay when you're supposed to pay more, then they just use the credits that they made from when they sold the excess solar energy.
Oh, okay.
Yes. So that's one way. The second way is some people are experimenting with is potential energy dams. So what they're doing is when they have excess wind energy, they just run a water pump, and then they just store water in a tank or water at an elevation. Yeah.
Oh, to be like kinetic?
No, you're storing water, you're converting kinetic energy, and you're storing water at a height, at a potential.
For kinetic.
Yeah.
Right? Because if it's higher, then it's
if it's higher, then it has higher potential. When it starts running, then that potential gets converted to kinetic through a turbine.
Yeah. That's
So
what I mean. Kinetic.
Yeah. So that essentially acts like a battery where you would store energy when there is surplus. So there's all this, but it's not widespread enough. And I mean, you can put solar panels on your roof, or you can have a wind turbine here or there, but if you're not offsetting the cost of it, that is how much water, how much CO2 is actually produced in manufacturing that solar panel in the first place, then the panel probably needs to run for 10 or 15 years to pay for itself, or to pay for itself in CO2 terms. But then what is it? Is the service life of the solar panel going to be 10 or 15 years, or is it going to be bad before 8 years or 7 years or so?
Right.
So that's something it's food for thought, you know.
So this would be something that's like discussed with the client, is like, here's like you want a solar panel, but what we're saying is that it might be smarter if we just make the building structure more sustainable.
Exactly.
Gotcha. Okay.
And solar panels don't come cheap, you know.
Yeah.
Yes.
Yeah. High efficiency solar panels, they don't come cheap. They're quite expensive. So again, as I was saying before, and at the pain of reiterating, 99% of the decisions are driven by cost.
Yes.
Always cost. So that the mindset as engineers, as responsible engineers, you have to change it. You have to tell them, hey, enough.
All right. Thank you, Reddy, for joining us.
Thank you, Reddy. Thank you.
Yes.
It was very nice to have you here.
Yes.
Sure.
And
it was very nice talking to you guys too. I mean, it was beautiful catching up and talking about these topics that are actually quite close to me personally as well. And yeah, hope we can talk again about this sometime soon.
Oh, we'll definitely be bringing you back on. We'll bring you back for another episode. Well, thank you all for listening to another episode.
Thank you, everyone.
On Fuck the Internet. We will see you all in the next episode.
Thank you. Take care.
Thank you. Take care. Bye, everybody.
Bye-bye.